All right. Good morning, everybody. Sorry, I haven't been able to attend the previous days here, but super glad it's being recorded just like this. So I'm Alec Engel. I'm going to be presenting two things in 20 minutes, leaving zero time for questions. So I apologize in advance, but you guys have my emails or email. So with that, we'll get started first on the open source project that we're working, and then we'll shift gears to the weather machine learning platform. So with that, I'll go ahead and share my screen. And I'm going to do my best reading voice because I am literally going to read from the slides today. So this is the title of our proposal. This is a HITS grant. We're working with Anaconda. So that's to extend open source software to streamline heliophysics data analysis. So pretty open title there. And then the second topic is a machine learning platform discussion. Presented by Brianna Mays, who's our principal machine learning engineer, and that's a project we're doing for Air Force Weather. And so with that, I think I'll just go through here. All right, so setting the stage. So this is verbatim what we put in the proposal that was awarded. So as heliophysics and astronomy data continue to grow, the community is faced with two options. You can convert the data to a different, and this isn't mutually exclusive, importantly, to different formats such as ZAR that can work seamlessly with different storage backends and is easily accessible or chunk-wise across distributed workers. Or continue to work with FITS files as the archival format of choice, generally speaking, for heliophysics, especially for remote sense data, and develop tooling to parallelize access to existing files. So under this project, we are working with these three libraries: Bouquet, FSS Spec, and Kerchunk. So what are these libraries? I'll mainly focus on FSS Spec and Kerchunk here. But we want to, the overall goal of this proposal is to streamline how scientists access, visualize, and interrogate and analyze heliophysics data and astrophysics imagery data, as well as time series data. There's an annotation component to this that's mainly in the Bouquet side of the house, but I won't be getting into that too much. So we're extending these libraries as previously mentioned. I got this pop up here that will go away. And the idea is that we're going to be demonstrating this through one of our dashboards here. So this dashboard has time series as well as some imagery data, and the idea is to show off some of that stuff. So again, forgive me for reading, but I think all of this information is important. So FSS Spec for Python is a project to provide a unified Pythonic interface to a local, remote, and embedded file system and byte storage. It is a Python library that abstracts, this is in other words, abstracts many storage devices to a common API so that other libraries don't need to worry about file location. Okay, but it's not ready for distributed computing approaches because the data may be required. It's scattered across many different files, locations that would be extremely time consuming to read in their entirety. So it has a reference file system. And this component allows mapping of arbitrary paths to binary chunks at other URLs. Kerchunk. Kerchunk is a new library that provides a unified way to generate views of chunked compressed data formats following efficient data access from file systems or cloud storage. It provides a flexible way to create virtual data sets from multiple files as required by the reference file system. Kerchunk does this by extracting the byte ranges, compression, information, and other metadata, such as coordinate systems, in the files and storing this information in a new object. All right. Custom indexing. So tangential to this stuff, the world coordinate system is important. So we held meetings with X-Ray and SunPy developers under this project effort to talk about X-Ray custom indexing. It's essentially ready in X-Array. There are pull requests already merged and others ready to be merged and will be in the next release. This will allow the use of custom X-Array.index to map from pixel coordinates to real world coordinate systems using the current mass in AstroPy. So the new world coordinate index, TBD name officially, will not sit in X-Ray, but will probably be in either SunPy's ND Cube or a separate project just for this purpose. There is a precedent for the separate approach here in GeoX-array, and so there's a reference there. For Earth-based coordinate systems, although this doesn't use custom indexers. There's a support for this functionality from both X-ray and SunPy. This effort will provide a use case. It is feasible to have a full implementation of the world coordinate system for X-ray within the timescale of this project. So that's what we're working towards. But there's always nice to have a fallback solution. So last bit here, we are developing an X-ray custom accessor along with demo code to calculate real world coordinate, either on demand or cached as deemed appropriate. This is a current approach recommended by the X-ray developers. The implementation will allow to proceed with other work and act as a fallback position if there are any unforeseen problems with the full implementation of world coordinate systems in X-ray. Sort of proving the technology, we want to put it in the Sprints dashboard. Some of you guys have seen a Sprints demonstration before, but we have time series data. That's where a lot of the annotation from bokeh will be demonstrated from a time series perspective, but also annotations on the imagery that we're going to be looking at. We're going to be experimenting with 2 terabytes of SDO data. We're going to be looking at it locally, also remote accessed on the cloud. And if there's any sort of bandwidth at the end of, or runway at the end of the project, we're going to be mucking around with some of those ML ready data sets on Helio Cloud and see how that goes. So these are some of the tools that we want to demonstrate the technology that it's going to be based on. So we already have some of this stuff, but it's not as scalable as we would like. And so these libraries, FSS Spec, Kerchunk, Bokeh, Intake, and some peripheral libraries will help us do that. And really the idea here is to be able to streamline analysis. So I want to do some examples. For instance, on the bottom left, that's an old IDL visual that I wrote probably 12 years ago. You're seeing the cooling of the loops there. And when you think like, hey, I can do this for all of the SDO data, I know when the X class flares occurred, M class flares occurred. Let me go jump to those start date times and put a bounding box around the post flare loops. And then all of a sudden I can do this probably, I can do probably 100 examples in a day, as opposed to me doing like 5 in 5 weeks, which is what I did when I was a bit younger. So just a couple. So I think all I have, and again, just in the interest of time for the group here, I'm going to shift gears to the weather machine learning platform. Again, this is what we're doing for Air Force weather, but you'll be pleased to know that it's not me presenting. So you get to listen to our wonderful machine learning engineer, Brianna Mays, present this topic. And I believe this machine learning platform, as you'll see, is one of the critical technologies. It doesn't have to be something exactly like it. But as everybody starts doing machine learning projects, and as Lika says, we don't want to have them all relegated to the GitHub graveyard. This is a way to actually put them into an active system. So with that, I'm going to go ahead and play this. Let me know if you cannot hear, but we did test this earlier. I'm just going to make sure.
Thank you very much. And finally, Brianna.
Okay,
Yep.
Can you hear Julie?
We sure can.
Thanks,
Yep,
guys.
good afternoon. So we should be able to see my screen now. So my name is Brianna Mays. I am a principal engineer with NextGen Federal Systems. Today, I'm going to be talking through the machine learning platform and how we use it to rapidly prototype machine learning models across a variety of domains. So you've all probably encountered the terms machine learning. Just a brief background though, there's a subset of AI where we're trying to learn from past data to predict on a new set of data. So instead of relying on a predetermined equation to solve a problem, our machine learning algorithm learns that equation directly from data. So these data-driven machine learning approaches have been shown to outperform statistical approaches in a variety of domains and settings. And our goal is really to provide the benefits of these algorithms to our customers across a variety of problem sets. The challenge, though, that we see is that the published results of the state-of-the-art models are difficult or sometimes impossible to reproduce. So the runtime environment of the algorithm is not well documented. So we're not sure which versions and packages to be using when we implement them. But even more detrimental to that is that the code and the data sets for these state-of-the-art algorithms are not released publicly. And because of this, some have gone so far as to say that we have a reproducibility crisis in machine learning. The good news is that because of this issue, the machine learning community is moving towards an open source approach. So premier conferences like ICML and NeurIPS are highly encouraging authors to submit code alongside their papers. And in fact, there's an official NeurIPS code checklist that authors have to abide by when they publish their code. And that includes requirements like providing training and evaluation code and also a pre-trained model. So that's good news for us as researchers. The issue now that we're seeing, though, is that all of this code and data is scattered across one-off repositories, and then each of those repositories provides its own pipeline for training a model, using it for prediction, and then evaluating it. So if we wanted to prototype a variety of models for a single problem set, we would need to recreate each of those pipelines, even though we know it can be generalized to a variety of problem areas, right? We have a training, we have prediction, we have evaluation. So what ends up happening is the teams are reinventing the wheel every time they want to prototype a new model. And that's costly, it's time consuming, but it also leads to results that aren't reproducible. So instead of having all of this code scattered across the web, what if instead we now have it in a single repository? And we also provided a codeless interface for the end user so that they could rapidly prototype their own model. And so that's where the machine learning platform comes into play. Machine learning platform, or MLP, as we lovingly call it, it provides the tools and techniques that allows for rapid implementation and evaluation of new models. So the platform takes the users through the entire machine learning pipeline from data curation and exploration to training and evaluating a model. So I've listed some of the features there on the left-hand side. What I'm going to go ahead and do is just jump into a demo video so I can visually show you what I'm talking about, and you can get a better understanding of the platform. So we'll go ahead and jump to the demo video. It is muted, so I'm just going to go ahead and talk through it. This is the Weather Machine Learning Platform, or WIX MLP. It is a specific instance of MLP that has weather forecasting models and weather visualization tasks. It is running within the Air Force Weather Cloud environment. So when I log in, it connects to their Active Directory, and it automatically recognizes me as an authorized user, which you can see up there in the top right. And this brings us to the projects page. So every user on the platform can create their own project, and this just helps to keep all of our work separated and organized. Today, though, I am going to be walking through the Weather Bench project, so I'm going to jump into that. And this brings us to the overview page of the platform. So you can see the tasks that have been run on my project there. You can see the tasks that have been run across the other projects on the platform. And on the very left-hand side, you can see the repositories and activities that are available for us as users. And I'm going to dive a bit deeper into each of those, and I'm going to start with the algorithms page. And if we click into it, we can see a general overview of the algorithms that the NextGen team has implemented and uploaded to the platform. So each of these algorithms references a state-of-the-art machine learning model. So we've implemented 27 of these algorithms across different task types. So things like object classification and text analysis. And in fact, if you go up to the top here, if you know your problem type, you can filter those down by selecting your problem type. So if we look at object classification, you can see the 6 models that are available for us for that problem. I am going to be taking a look at Weather Bench today, though, so I'm going to clear that out, and we're just going to scroll over and view the details of the Weather Bench model. In this page, the details view, we see that it is a time series prediction model. We provide a brief summary of the algorithm. So it's a convolutional neural network. It has periodic convolutions, and it's meant to be a baseline for the Weather Bench data set. So the goal of this CNN is to ingest the Weather Bench data, which consists of geopotential and temperature values, and then forecast those same values into the future. And we also provide a resource link here at the bottom, and that points back to the original source code if the user wanted to find out any more information about the model and the data set. The next thing we want to take a look at is the implementations page, and implementations are what adds code to the algorithm. So in our case, let's go ahead and jump again to the Weather Bench implementation. So each implementation references a Docker image, which includes the code and the necessary environment variables that's going to be built upon execution. So we see now we have this image ID, and that points to Amazon ECR, where we have uploaded our Docker image. We also see that we've implemented the model in TensorFlow, but because we're utilizing Docker images, you really don't have to worry about any of those required frameworks and packages, but the Docker container is going to take care of that for us when we actually go and train our model. So we have our model. The next step, we need data to train and predict on. So I'm going to go ahead now and take a look at the data sets repository there on the left-hand side. I've already uploaded the raw weather bench data that we're going to be working with today. But you can see the addition sign there on the right. You can easily ingest your own data to the platform through that UI. But let's scroll down and take a look at the raw weather bench 5-degree data. And this view is going to show us the contents of the data. So you can see that it has files for 1979 to 2018. We have geopotential, we have temperature values. So this just gives us an insight into what's in that data set. However, it's nice to be able to actually visualize that data as well. So we have provided this Explore functionality to the user up here in the top right. And so if we click into it, we get this nice Jupyter Hub dashboard view of our data. And so we have this view shows us we have two parameters. We have a geopotential and temperature parameter. We can swap between them. And then the plot will adjust accordingly. We also know it's temporal data, so I can in fact ensure that it is 1979 and it ends at December 31st, 2018. We never want to train and test on our own data though. So the first thing in our pipeline is going to be able to transform our data into a training set and a prediction set. So if we look at the transform activity, this is a form that you would fill out to just create those new training and prediction data sets. I've already done that for us. So I've chose my original data set, chose the transform I'm interested in, provided the dates of interest, and went ahead and kicked off that task. And I visualized it the same way. You can see now I have a trained data set that's 2015 to 2017, and I have a predict data set for 2018. So we have our model and we have the data that we want to train and predict on. So the next step is actually going to be training our model. So I'll walk you through what that looks like. We do select the train activity there from the left-hand side. I want to select my untrained weather bench model. This is just within our models repository. And then I select my data set that I just created, the trained data set. These are the hyperparameters that are available for the user to change. So for instance, for this demo, let's just train it for a single epoch there. And now we just need to fill out the metadata for our new resulting model. So we're going to give it a new model name, and the green check mark ensures that it is a unique model name. So when it shows up in our repository, there's no conflicts. We're going to give it a model summary. And then finally, we're going to give it a task name so that we can monitor it within the task page. We will click through next here. I just need to review my selections at this point and then kick off the training task. I'm going to show you what the results of that looks like. I've already went ahead and ran that. So we're going to go to the task dashboard, look for that task that I created based on the task name, and just kind of view its details and see what the results are. So in this case, I have a new resulting model called Weather Bench Train that is now going to show up in my models repository. The next step at this point would be to take that model and use it for prediction on my predict data set. It's a very simple form, just like we filled out before. So I'm just going to show you the results of what that task looks like. I'm going to go to my task dashboard once again, look for my predict task. And now instead of a resulting model, what we're going to see is we do in fact have a resulting data set for my predictions. So I can look at that straight from the details view here and get some more insight into it. And what we're going to see is there's two files. I'm interested in this predictions.net.cdf file. That's where my predictions are going to lie. And just like we've explored our other data set, we can do the same thing here. And so this is for a single epoch after training. You can see how my model is performed during the year 2018. I have predictions for both of the parameters. And I've also uploaded my ground truth data. So ideally, this is what my model would produce, right, if it was 100% accurate. So you can scroll through there and kind of visually see, okay, my model isn't doing anything wonky. Qualitatively, that looks pretty good. But my last step is to put some quantitative metrics behind that. So we're going to go up to the last activity here, evaluate. I'm just going to quickly show you what that form looks like here. Once again, it's just a matter of filling out that form. We're going to jump to the tasks for this and see the results of my evaluation. So I'm going to look for my evaluate task that I have already ran. And if you scroll down now, instead of predictions or model, what you're going to see is actual metrics that are backing up. So I have weighted RMSE, weighted accuracy, and weighted MAE for both of those parameters of interest. So I'm going to go ahead and just jump out of this demo and get back to my slides here. So I demoed weather application that we have within MLP called the weather bench model, but we've implemented a total of 27 algorithms across 12 task types. So the table on the left there shows the algorithms that we have registered currently within the platform. And then the right are the task types that they cover. So all of the algorithms, though, are generalized and reusable components. So on average, it took our team 9 days of development time for each algorithm. But because we have generalized them, if you adhere to the documented requirements for your data set and upload it to the platform, you can use any of the registered algorithms for your problem type. So what ends up happening is that 9 days for implementation is actually a one-time cost, which means that we're reducing the time and costs associated with this rapid machine learning prototyping.
3 minutes.
Thank you. So I listed here some of the applications that the NextGen team and others have studied for prototyping within the platform. So I've already discussed some of our weather analysis and forecasting capabilities. I demoed Weather Bench, where we are forecasting weather parameters into the future. We also have a team working on lightning prediction, where they are attempting to forecast lightning based on input GAL1 data. We've also studied a novel modulation recognition approach. And additionally, we can handle time series modeling problems. We have a team looking at predictive maintenance. And we have quite a few teams working on object detection. So things like detecting contrails or vehicle detection and tracking from the UAV. So this list just gives you a high-level overview of some of the tasks that are performed on the platform.
Okay, I think I'm going to stop it there in the interest of time. I think you guys maybe with that video got a good sense there. So I think that's it. So Julie, thank you very much for the opportunity to present here, and Brianna virtually recorded. So thank you.
Of course. We'll move on to our next topic, but if anyone has questions, feel free to put them in the chat for Alec. Let's see. So next up, I believe we have Sean presenting on some various PyHC website stuff.
Yes, we do. Also, yes, echoing in the chat. Nice work, Alex. And Alec, it's totally cool that you went over a little bit, because I actually don't have a whole lot prepared for this little bit. It was definitely worth hearing more of that presentation.
Yeah, you bet. Thanks, guys.
Yeah. So let's see. I'll go ahead and share my screen here. So I'm going to be talking about getting a PyHC DOI and then maybe changing our website URL, and hoping to get some ideas from people who have opinions about this kind of stuff. Hopefully you're seeing a poll right now, though.
Yep.
Taking a break to point out to people that we sent out this very short poll in the follow-up emails and put it in the Slack general. This is just asking about if you would consider attending a PyHC 2024 solar eclipse event. We're trying to swing it so that we do something together as a group somewhere that would be cool and work related. We're looking at tests right now. They don't actually start planning the 2024 tests until early next year, but they're already putting us on the docket to discuss bringing in our little idea to do some real-time data visualization during the eclipse. So I'll paste a link to this in the chat after I'm done talking here, and look for it again in Slack or in the emails, please. And thank you. Anyway, moving on to, so we need a way to cite PyHC is basically the main motivation behind this. When we write papers or when we publish software, things like that. It was pointed out to me by, I want to say it was Nick, actually. Nick Murphy, are you on today? I don't see you. Nope, don't think so. But yeah, I'm pretty sure Nick is the one that pointed out to me that DOIs had a page for all the things you could get a DOI for, organizations being one of them. Normally you think of getting a DOI for like a research paper or something, but you can get them for like web apps and orgs and stuff. I kind of went down the rabbit hole of starting to make a DOI for PyHC, but then I learned about a new thing called a ROR ID. So I was gonna, I guess, show you the draft real quick and then show you what I learned about this ROR ID thing, and we will maybe come to an agreement on whether or not a DOI is necessary. So the main thing with getting a DOI for PyHC is you have to shoehorn a lot of required fields. So like, it's pretty easy to say, you know, what's our URL? But then you get to the second one, the creators. I already got stumped on the second question, sort of. I ended up putting Goddard and LASP because we're technically the groups that came together and started the thing. Aaron from Goddard, and it was actually Alex Ware from LASP at the very beginning here. So yeah, you get to titles, and again with publisher and publication year, all of these things were seeming like we could come up with answers kind of, but they felt sort of wrong. So I actually had emailed the support for this data site place where my work like makes its DOIs, and they pointed out that we're using these ROR identifiers to state who Goddard and LASP are, and they recommend I look into those. So to give a quick little image here, I actually didn't know about ROR IDs down here in the bottom left until they had told me about it through the support email. But apparently I can feel fairly good about that because it's a really new concept. I think they didn't exist until 2019, and they just started becoming like accepted by groups as of last year. So, well, Aaron, did I hear you pop in something about ROR, or was that
Just that it's been a few years,
one more time?
been around for a few years.
Been around for a few years, yeah. 2019 is when their blog says they started actually
Yeah.
organizing. But I'm kind of liking this little diagram here because it kind of shows a nice ecosystem where everyone can reference everything equitably. You know, we've got our org IDs as researchers. I imagine most of us on this call have an org ID at this point. And then DOIs, obviously, for like related research outputs, but then you can have ROR IDs for research organizations. And then they even have this Crossref funder registry for funding. So you can kind of identify all of these different things. And I went to look at the process for making a ROR ID right now is pretty weird. There's like one community who does it, and you have to sort of just request that they please look at your organization and you know, think about adding it. They have a little Google form that I filled out, and they have a bot that from the Google form generates this little GitHub thing, you know, just actually asking relevant research organization questions like what's the name of the org, any publications that have been published under us, related organizations, our abbreviation and stuff, blah, blah, blah. I've got
Is
one.
PyHC a research organization? It's not clear to me it is.
Yeah,
It's not-
they
It's not LASP.
it's not LASP. The organization type that I ended up here, I went with nonprofit. Out of the options they had in this little drop down, that seemed to be the most fitting, because I mean, yeah, correct me if I'm wrong, Aaron, but we are a nonprofit, right? We're sort of just a group that's organizing this stuff.
It's not a non-profit. It's not technically a nonprofit. It certainly has no legal status as a nonprofit.
We don't have legal status as a nonprofit.
No. You can't make contributions to it.
Let me see here. Do I have
the
like,
options again for it?
I guess I don't see it as a research organization.
I'm seeing really quickly if I can get to that Google form. I think
What's-
Research
what's the
organization
use
sounds
case?
better than nonprofit, but
yeah. I would have to click through this really quick to get to the question. I think I'm gonna just do it really fast. I'm actually gonna submit this, so hopefully this doesn't really matter what I'm doing. Yes. First of all, it's saying you have these requirements for being a Aurora. You have to make sure that we're a top level organization, not like a department in a university. We are that. And check if it already has a Aurora ID. We did not have one. Okay, so that part was fine. Type of organization. Here's what we had right here. Education, which is like universities and stuff, healthcare, like hospitals, a company. We're not a private for-profit. Archive, nonprofit, government facility.
I mean,
See,
that's what I did. SPDF shows up, has a ROR ID because I put it in as an archive.
oh,
But
Well,
facility,
Do we consider PyHC to be a software archive?
well, I'm thinking facility actually looks better. It's a dedicated research area.
yeah, but wouldn't the facility actually be like a physical building?
That's what it looks like.
Yeah, maybe. I'm thinking government, maybe.
No. How about
No,
other?
It's not a government organization.
It
Okay.
could do other and then let them.
Others certainly fit.
Yeah.
I mean, yep, there is that other staring us right in the face.
Go for it.
Probably
It
the one
doesn't
I
really
go
mean
for.
anything.
Yeah,
What is the use case here? Why do you need to cite PyHC as opposed to citing software?
well, I mean, it just makes sense for when we're talking about PyHC as a group, like for example, in the paper just published by Julie and Arnaud et al., where we're talking about updates to PyHC as a community. It's nice to have one identifier to say who you're talking about. Plus things like my executable paper, where I'm saying we're a group of researchers from the Python and heliophysics community showing how to use these various packages that we house. You know, the reference I ended up using was like a 2019 abstract submitted to some conference talking about PyHC. But it'd be nice to have, you know, an organizational identifier for us.
I've also been required to do so in a few papers I've put out.
Have you? Like for PyHC specifically?
When I was talking about PyHC in a paper.
Okay. Well, we're kind of in the middle of a workflow right here, because what happens is after you submit this form here, it generates a GitHub issue, which gets stuck on this big old board here. They have a whole bunch of, you know, to do and second review, blah, blah, blah. We're apparently in a second review stage right now for adding PyHC to the ROR ID. And I have this one, this one person commented basically saying that, so I think this is fine to add. Like he agrees that we fit with them. I could post a little comment in this issue about the nonprofit versus other. And they actually have humans that go through and take a look at everything to kind of check what you're putting. Like someone will actually go through the HelioPython website. He actually like gave a quick little summary of like what we do from his point of view. So I'll go ahead and make a note here to ask about the if we're at other, maybe profit versus other in your ID. So that's in the process there. And I guess this sort of comes back to, if we're going to be getting this ROR identifier so that we can be identified as people like Goddard and LASP get identified, I'm sort of thinking I'm going to bail on the idea of making a DOI. This is just a draft right now, and I could just, you know, not publish the draft if I felt like it. So from the discussion I'm hearing, I think people are more or less in agreement. I'll give someone a second to think about maybe they disagree and they really think we should have a DOI.
The DOI folks certainly construe themselves pretty generally, but I think it's in some ways difficult and misleading to have DOIs for absolutely everything. But
Yeah, like who publishes PyHC, right? Like I gave Goddard the credit in this draft because that's where the money comes from, and it would be like stealing credit if I put like myself or Julie or anyone else. But yeah, some of this, like I said, shoehorning. So I think in the interest of time, I probably won't.
I'd vote against DOI and for ROR if anything.
Yep.
I
agree
think
with you.
DOI is still useful because I mean, you're actually changing your website, and instead of mentioning any website in a paper, a DOI would be sustainable.
That's the next bit, because you have what I'm going to talk about immediately right now is potentially changing the URL on our website. So
Exactly. So this is
salient
where
point.
DOI
Yep.
is useful.
Which that it also makes me a little bit
Doesn't
nervous.
the ROR does the same thing, doesn't it?
Yeah, ROR also you stick a URL in there, but then you can go through this Google form to update the URL if it ever changes.
Yeah, right. So I would still think ROR is okay.
Yeah, especially from this little diagram, it seems to make sense. All right, so our website here, for people who aren't aware, let me see, is Pete Riley here on the call today? Pete, you here? Nope, not seeing you. Oh darn, could have been cool to have his opinion in here. Pete Riley actually recently set up a new domain for us. I apologize for the small font up here at the top, but this heliopython.org has been our URLs for as long as we've existed. But fairly recently, PyHC.org started working too. All it does is it redirects to heliopython.org. But there's this annoying thing about that, because whatever mechanism Pete used to set up the redirect, HTTPS is not supported. So if you type HTTPS PyHC.org, you end up, it spins for a while and then you get an error saying we can't resolve this this domain. But then if you go and you delete the S, the redirect goes right through. That's just a technical limitation with technically, even though HelioPython is under encryption and stuff, the domain providers couldn't do the same with the PyHC.org redirect. So in the interest of pulling the Band-Aid off early, I've sort of been thinking about just going ahead and reversing this situation so that PyHC.org becomes our actual URL. And then we could have heliopython.org be redirecting to PyHC.org, which would help some links stay active. I'll point out that like subdomains still work. So if I do pyhc.org/projects, it brings me to heliopython/projects. The same would be the reverse there. It just feels like unfortunate timing because we just had the paper published by Julie and them, and we have my executable paper going through review right now where we've said, you know, here's our website, go check it out. And it'd be a shame if someone, you know, hit HTTPS HelioPython and couldn't find it. They went, what the hell? I just read this paper like published last month and now the URL is broken. So I don't know. I'm considering that. Does anybody really have a strong opinion for yes, we should switch over to pyhc.org immediately?
If
Do
it
you
doesn't,
mean switch over to having the HTTPS work?
Yeah. Have that be our official URL and HelioPython would just redirect to PyHC.
Sounds like it fixes a problem, actually. Now, would it work for the S and without the S?
It would become, this URL would no longer be valid, actually. You would have to remove the S and then this would be valid. I
I
do not
think it's
That
a
know.
doesn't
bad,
seem like it
bad
fixes
idea.
the problem.
It's a bad idea to remove the S. Everything's moving toward having the S being the required thing.
No, absolutely. And it's browser default. Well, actually, no, browsers try both, actually. The browser by default will try HTTPS if you don't specify, and it'll fall back to HTTP if it fails. So if you just type in this, it would work around fine. Yeah, it's unfortunate that the way encryption works, you can't do an encrypted redirect, so to say. I mean, the alternative is just to kind of sit on this for a while and just know that we plan on making the change at some point. But then it feels like we might be giving ourselves more technical debt because we keep publishing more papers and stuff, redirecting people to this website. It's just more of the bad URL floating around out there, I guess. So I'm feeling a rush to make the switch over just because PyHC.org feels so much better. We kind of use this HelioPython verbiage in like the very first year of our existence, back when like Steve Christ was running the stuff, but we haven't been using that for years, and we say PyHC all the time. So,
So PyHC.org does not have a secure link, is
No,
that the problem?
what it is right now is heliopython.org is secured. You type the S there because there actually is encryption and it actually is safe from some web attacks and stuff like this. PyHC.org, even though you're not giving it an S, it redirects to the encrypted version of this page. So there's actually no way right now to visit this website and have it unencrypted. So like we're safe from a security standpoint. It's just a matter of what people are going to be typing into their URL bars to find us.
But it's just a technicality. I mean, those two domains sounds like they're registered on different services. If you get them, the domains registered with the same service, they could both point to the same content.
Oh, there's an idea actually.
Who owns PyHC.org?
PyHC.org, Pete Riley with, oh goodness, I forgot the name of his organization already.
Predictive Science.
Thank you.
Yeah.
Yep. He runs like the website domain for their company and stuff. And he had just offered at one point after we were talking about this at like a telecon maybe last year or something. He was like, hey, I do domain stuff for my company. I could buy you PyHC.org real fast. And within maybe an hour or two of suggesting that, he emailed me saying, hey, I went ahead and did it. Which was awesome at the time. And I actually like the idea
But it wasn't secured.
Well, there's actually no concept of security with this. It just simply redirects to our secured page, and PyHC.org is just this transitional thing. That doesn't exist.
I would suggest getting ownership of the domain before making it our primary.
Yeah,
And
get
combining them
ownership
together.
and make sure it's secured, and then go with it.
Yep. I mean, now that you say that, it seems like the obvious solution, actually. Let's see here. I'll actually have to.
Yeah, you make one an alias of the other or whatever, but
Yeah, if that's possible, that would be way more sane, because I wouldn't want, because then nothing would be broken. Then anyone could type any permutation of HelioPython or PyHC and it would just work.
Yeah.
I like the idea of Pete and his company doing the domain stuff for us because it spreads apart the ownership of PyHC a little bit. You know, we try not to be this top-down governmental thing where me and Julie tell everybody what to do. And it kind of makes it feel more like we're all on that level with someone else running it. But that does put me in the place where I don't have access to that back end. And I actually forgot who currently owns this. I think it might still be Steve Christ personally paying out of his own wallet to renew this every so often. So I will, I'll make an action note for myself to track down who actually owns this domain right now. HelioPython.
Must be Steve.
Yep. And
But I think, I see no problem with having LASP have ownership of these kinds of things, because it's not I don't think anybody in the community is feeling bereft of not having a URL in their name.
and HTTPS. Cool. I don't think I need to belabor that discussion any longer. I think I'm already a few minutes over the allotted time anyway. So I'll call that the action here. I will, with the ROAR ID thing, I'll contact them on GitHub and ask about if we should change our selection to other from nonprofit, because we're technically not a nonprofit. And then I'll figure out the stuff with these domains and try to make it so that you can type HTTPS either of them.org. And then we'll be in good shape as an org, I think. So stop sharing. And I think at this point, I'll turn it over to Arnaud. That we're going to abruptly switch gears to a COSPAR ISWAT thing.
Yes.
Thank you.
Take it away.
All right. Okay. Okay, so let's move on to promoting open science with COSPAR and ISWAT, and with an overview and some updates. So some of you have already seen some of these slides, so apologies for that. I will just summarize quickly what I mean by information architecture, and then we will talk about the Heliophysics Data Alliance called ID, the COSPAR initiative for the Space Weather Roadmap called ISWAT, and some examples of the impact of these two organizations on open science, and I will finish by showing what we are doing for minting DOI for data sets at ESA, and what are our recent developments. Okay, so well, information architecture is really all about science. It's about data format standards to use data analysis, data access protocols to use data distribution, metadata registries to find distributed data sets through metadata, open source software to grow data usage through open science software, metadata standards for observations and simulation to eventually boost data simulation comparison, AI/ML ready data sets to help the use and comparison of AI/ML algorithm, science platform and cloud computing like NASA Helio Cloud or ESA Data Labs to support collaborative, sometimes large-scale data processing and analysis, and DOI for data citation and discovery and access. And all of this needs international coordination to work. So in heliophysics, there's a big history of missions back from 60s, 70s. In the 80s, this is where a common data format was created with compulsory set of metadata called global or variable attributes. That was so-called, it was related to the International Solar Terrestrial Program. So this is CDF ISTP. And for all the in situ plasma data at NASA, at SPDF, everything shall respect this standard. But okay, apart from this standard, this data format, metadata standard, there was no real organization to coordinate efforts in the heliophysics data environment. So, and this was really contrary to other domains like astronomy, where since 20 years, they have the International Virtual Observatory Alliance, which has led to a number of advances in data model, metadata registry, data access layers, and so on, and that we use actually heavily at ESA. There is also the Planetary Data Alliance that you know, and its actual format PDS4, and a lot of work of sharing tools, software services, making compatible archives to exchange data across these space agencies. Now, the Data Alliance for Heliophysics was created in 2019 after an original meeting at ESA, but it was formally created in 2019. And in 2020, we set up some working groups. Last year, we had some invitees from WMO and GNSS experts to present how they use their what is their data format and metadata registry, and because there is a clear overlap in the space weather domain in particular. And this year it was organized by JAXA, also virtual, and hopefully next year we're gonna meet finally face to face again. Okay, I'm not gonna go through that in detail, but basically the goal of IDEA is the use of common standards and services to boost data sharing and enhance science. The role of IDEA is really to foster communication and to identify these standards and services to best serve the science needs. So as I said, we have a creating working group in IDEA on metadata, on the UI and data access layer, on space in particular, on Python, and more recently on science platforms. And I wanted to share with you a few positive outcomes of this organization, in particular in the astronomy domain and in heliophysics at ESA. We have on the back end we have a table access protocol. We use the table access protocol, which is the IVOA data access protocol standard, and it's implemented across our heliophysics archive. And on the other side, the virtual solar observatory is heavily used by the solar community. It's built on an old data model, but it's connected to SolarSoft and SunPy, and we wanted to have our data visible through the VSO, and so we started some communication with the SDAC and people managing the VSO, and after some time we start to see our data. We are lucky enough to start with the E letter, so we appear on top, so that's good. We have now the Proba2 served through the virtual solar observatory and SolarSoft, and hopefully soon through SunPy, but basically we really want our solar orbiter data to appear there, obviously. So because it has been done already with our top server on Proba2, this is exactly the same system for solar orbiter. So that's so we happy and hopeful to see our data distributed by the virtual solar observatory maintained by SDAC. Some other positive outcome of ID, there was clearly a need at SPDF to that we provide our data from the cluster mission in CDF ISTP. We were providing this data in originally in the cluster exchange format, which is our ASCII format to store the data. And we had a converter to provide those data in CDF, but not in CDF ISTP. So we did develop a software to do this extra step. And this software is an open source software, and it also converts PDS3 to CDF ISTP. Now we have upgraded the Cluster Science Archive also to this table access protocol. And there is ongoing work to add on top of this the heliophysics API developed by NASA called HAPPY. And we have some support by the Applied Physics Labs and NASA to help us doing this. And once they've done that, We will implement that also on top of the Solar Orbiter archive tab server to serve the in-situ data from Solar Orbiter. There is some action from the last ID meeting, and this is to develop a registry of registries, maybe an IVOA-like registry. This is to be discussed. And we want also to upgrade our tab server to be compatible with EPN tab, which is the Europlanet version of this protocol. And so our our servers will be visible through the Europlanet Vespa system, which is basically a website, a registry where you can find data sets spread across the globe in planetary and heliophysics. Another positive outcome is, after some discussion with people from the SPIDAS at UCLA, cluster data are served through the SPIDAS, and SPIDAS is really the leading multi-mission archive software for solar wind magnetospheric and ionospheric plasma physics, and it interacts directly with the table access protocol server. And not only SPIDAS, but also PySPIDAS, and that's of course really important. So we have a special module that has been developed for this, and what is great with PySPIDAS is there are a number of Jupyter notebook that have been developed for MMS that are that are easily compatible with the cluster data. So we need to do this extra step, but there is already a lot of Jupyter notebooks that we could use for this. So clearly, we felt the need, like everybody else, to promote Python tools for heliophysics data access and analysis. And this became a working group in ISWAT. So ISWAT is the International Space Weather Action Teams. The goal is really to define the new international 2025-2035 space weather roadmap. It involves over 500 scientists, and this activity shall be completed by the end of 2023. So the way it works is that you have a number of scientific groups by a science team, from the core of the sun to its impacts on Earth and elsewhere in the solar system. And you have overarching activities to support those groups. And two of them are the information architecture and data utilization, and the other one is innovative solution. So the way it works is that people can propose and define working groups or action teams, and every of these action teams has published a paper of what is the state of the art and what should be done over the coming decade. And the output is 7 papers that have been published or are under review. Some great paper led by Rebecca Ringett on innovative forward-looking solution for information architecture. One very long paper, but very interesting, on metadata, data protocols, DOIs. One on ML-ready datasets, and on Python, as we will see in more details now. There have been some actions out of this ISWAT initiative. There is also one paper on data model comparison and one on executable paper by Sean. So, well, starting with this group, so basically last year, late summer 2021, and we organized a mini ISWAT workshop by invitation only. That was organized by NASA, led by Brian Thomas, to look for a way forward on PyHC with several questions, including a possible AstroPy-like integration, or how to foster and increase the PyHC community worldwide. And everything is described in this NASA technical report that you see on the right, and you have the link on top. And so one of the outcome of this mini workshop was that we need to increase the PyHC community worldwide. And so the first PyHC summer school was organized beginning of June 2022 with the core developers of the core packages of PyHC, including PySpeedas, SunPy, PlasmaPy, etc. And the outcome was we had participants for 43 countries, not only Europe and North America, but really literally from all over the world, or all continents. We had 300 people online. It was run through NASA Helio Cloud with 60 people at ESA, because that was the COVID limit we had at that time. And some participants also followed the event through YouTube, as it was live streamed, and as it was nicely organized by Sean. And we have recorded all these sessions. So one of the outcome of ISWAT was also to produce this paper, so on PyHC, current status and future outlook, that has been published online, and it's open access since last month, 9th of October 2022. I put the DOI of this paper on top. And for the International Space Weather Action Team, we have an overarching paper. So to give you a flavor of this paper, it's divided into 4 parts. So one part is on a fair approach with a section on space metadata registry, another one on data standards, including ISO standards, third one on data access protocols. So that's for the fair approach. There is also a section on open science, which will be written by Judy and a member of the Camodo team, one on executable paper, and a subsection on DOI. The third main section is on innovative solution on AI, ML, and GPU computing. And the final section is on collaborative science platform, which will include also cloud computing. Right. So I will finish. My last part is on DOI. The DOI that we have minted at ESAC for our data sets. So this is across not only heliophysics, but also planetary and astronomy. What we've done so far on heliophysics is to have a DOI for every experiment we have on each of our mission in heliophysics. And next year we'll generate DOIs for every data set. And we didn't mint only DOI, but also we added a JSON script to make it findable by Google and other search engines. We published a paper about that last year. And in our JSON script, we have you need to put the name and the description. That's the minimum you should put. But you can add a number of properties that have been defined by schema.org, and one of them is keywords. And so you can search, easily. For instance, our catalogs on the Gaia mission. If you type in Google dataset search Gaia DR3, you get it immediately, and it points to the description and the archive. And for golf, this is the same. This is one experiment on Soho. And if you go to that link, so you have the landing page on the left, and you have a link to the mission long files, which are basically 3 files covering 26 years of data from Soho. And that's basically all the data you need to download. Unless you're a super expert and want to go back to the raw data, but this is not my advice for golf. Okay, and you can add really scientific terms which help to look for data, like if you're looking for electron 3D distribution, data that have been measured by cluster, because it's in the keywords, you will get a link to the rapid and the PIECE experiments that provides this kind of data sets. And you can also use it on directly on Google to find a description of the Solar Orbiter Foxgate experiment. Right, and of course for these keywords we put it manually on the for heliophysics experiments because we had only 50 of those, so that was easy. But for other missions like XMM, which has over 4,000 DOIs, you cannot do that manually. And so we looked for ways to add those keywords automatically. And so this 4,000 corresponds to the 4,000 proposals, observation proposals that have been selected by XMM and that have been implemented and generated data. And so to show you basically this is the abstract of the proposals where they explain quickly what they want to observe and for how long. And what we've used is some natural processing software which extracts relevant keywords in a text. And to do this, you need to work with, of course, the mission specialist to define the typical keywords or patterns that you expect. You need to work on stop words to really extract what matters in these keywords. And this natural processing software or algorithm, we selected one called REG, which was developed by MIT, and it works very well. So we had a stagiaire doing this, and it puts some weight on the keywords it extracts, and so the top is 10 and it goes down to 1. And so then you put a threshold on the keywords you extract with their weight. And this is how we managed to populate the keywords in the JSON script of the DOI landing page for 4,000 abstracts like this. And we're going to do that for other missions, similar missions like Herschel or Cheops. And yeah, I think it's a way to improve the findability of our data sets on Google Dataset Search. We have also a data discovery portal. I think NASA has got a similar data portal. And in the midterm, we really want to do our DOI on the fly, where you select whatever data sets we have on our archive and generate a DOI on the fly. You can immediately use in your paper to point from the paper to the data in a very easy way. Okay, right. So clearly, international collaboration through the Geophysics Data Alliance ID has led to a number of improvements, and it helps everybody. It's both ways. I'll give an example here. It led clearly to a wider distribution of, for instance, the cluster data. Since the beginning of 2022, we serve 70 terabytes of data, and that's about 7 terabytes a month, and we used to distribute something like 1 to 2 terabytes. So I think it's a great improvement. And also, those data are now accessible through PDAS, SPIDAS, PySPIDAS, or the VSO for the solar data. The DOI helped and are helping to improve their discoverability, and soon we'll bring. We're in the process of bringing all this data to ESA Data Labs, which is a collaborative science platform that will be released next year. And with that, I'm going to stop. Thank you.
Thanks, Arnaud. Anyone have a quick question or two? before we move on?
Just a comment, Arno. Yeah, it's very nice to hear what's going on there again. So for the idea meeting next year, there was some email exchanged about places and times. So we can talk about that at some point there. I have actually gone ahead and reserved a room at APL just because it's so hard to get it. But that could be for like, I think it's October 12 and 13.
Okay. And do you want to organize also this ADAS workshop?
Yes, that would be the same week. So that would be 9, 10, and 11 of October. If this all holds, this is all very preliminary, but then that would be like a heliophysics data and computing workshop, a kind of technical exchange workshop, and then followed immediately by an idea meeting. So that's an option. You and I should talk about that and others. But
for
anyway.
me, it's all fine. I have nothing booked for October 2023, so I'm totally open.
Right.
No, I think it's great. It looks great.
Rebecca.
I know, I have a quick question for you in the chat.
A vision for Komodo for the yes. What do you mean by you owe me a vision?
I think you were asking for me for a few paragraphs, so for the O2 paper to summarize the infrastructure ones and then the Komodo paper. Yeah, okay. That completely fell out my brain. When do you want that?
Yesterday. No.
Well, I slept since then, so I'll have to work on that.
No problem. No. You know, it's also my fault. It's my work to remind people about what we've been discussing. Trying to gather all the different parts to make this overarching paper. So, yeah, I mean,
How about high priority?
yes, yeah, no,
Top
that would
3
be
priority.
great. The best would be before AGU, so within a month or something like that.
I was aiming before Thanksgiving, but that's a good fallback. We'll see what happens.
Even better, the sooner the better. But yeah, that would be great.
The good quality is better.
Yes, of course.
All right, sure. I'll write it down. Thanks.
Great. Well, thank you again, Arno. And if anyone has any more questions, feel free to throw them in the chat. But now we'll move on to Russell talking about a potential CSSI proposal he's working on.
Hi, can you hear and see me?
Yep.
Great, thank you. And thanks, Julie, for fitting me in. So I don't actually have any slides with me today, so you're just gonna have to deal with my video. But I am hoping to get a proposal into CSSI, which is a National Science Foundation program, which stands for like cyber, software, something, which I forgot, and then infrastructure. That part doesn't really matter, but CSSI has like 3 stages of proposals. One is called an elements, which is for like individuals or small groups. And then on top of that, it has something called frameworks, which is for larger groups, and it correspondingly has larger budgets. So for framework proposals, it can actually be as long as 5 years and up to $5 million. So that's a very kind of healthy amount of funding. So I'm bringing it up to the group just because this is, I've tried a few times now to see if I can get funding not only for myself and PySat, but to include other people in PyHC so that we can more substantively connect packages together over a longer time frame. Of course, there are some funding programs in NASA and stuff, which is great, but those tend to be on the smaller scale size, so you can maybe get, like one person or group, small group to couple, one thing in there. So I was just hoping to see if there would be an opportunity for funding for more people for longer, since that, getting funding is a typical thing. The challenge that I found is the NSF rules. So NSF is pretty restrictive in who it funds. So it won't fund for-profit businesses. It won't fund anybody who's like a NASA civil servant or something else like that. It won't fund anybody internationally, and on and on. So I have gotten some responses to my previous announcement on the PyHC list, but all of those ended up being for people or groups that the NSF will not fund. Incidentally, that includes everybody else on the PySat team but me, pretty much. So, and I have had a discussion with the NSF people, and I asked them if they would hold all those restrictions against me, like if I can't form a large group, because they just will refuse to fund them, and they said that they will. Which, I mean, I get it, they're rules, but it's a bit of a bummer. So I just thought I'd bring up again, though I know there's a number of NASA and other and international people on the list. So, I mean, that's probably most people here are already prohibited. But I just thought I would check again because there is a possibility for 5 years and significant amounts. So the general idea is that, you know, on the PySat side, we would just be doing PySat type things. Hey, Katie. Doing all kinds of PySat things, extending out, making more general, working on utility. And then for other packages, the general idea I have is that those packages would work on things that they need to do for their packages. And then in addition, work with me to integrate that package into PySat and integrate PySat into that package. So form hopefully two-way bridges between those packages and just kind of strengthen ties within the community and provide, you know, funding. So that's pretty much it.
Yeah, Rebecca has her hand up.
Oh, yes, Rebecca.
Are you talking about basically taking the adapter work that was presented earlier and extending that to include PySat?
I've been busy with the proposal submission earlier this week, so I have not attended the previous day. So I don't know exactly what you mean by adapter work, but
who's here? I don't see them. John, you would know. John Vandergriff, can you can you pipe up and explain what?
Oh, yeah, Sandy presented that. He's here too.
Oh, I didn't see him.
Yeah. The yeah, I don't know if you
We
want to
made
speak.
adapters for 3 packages. We discussed adapters and how the community could move forward to it. So Russell, I sent the slides to Julie. Look over the slides and Julie's cat, and look over the slides, and then we can talk further about it, because it does dovetail nicely with what you're doing. It'd be nice if more adapter work is done, influenced by what the community said when we did the Miro board on Tuesday. So we can provide that to you as well.
okay, thank you. I can do that. But I believe you're a NASA person, aren't you?
APL is a
okay.
not-for-profit, and we are
Okay, perfect.
even if we don't participate, I can at least you know, give you information that can help your proposal.
Oh, great. Yeah, I did. Like one of the ideas I floated on the list was actually, you know, doing a connection with SunPy, and then, you know, providing funding to the SunPy. I mean, not me, but the project. You know, providing funds to the SunPy team to fund the development of the whatever data format or new data that they were going to produce. But the person that was interested in doing that was international, so that kind of fell apart. But
APL should be fine, shouldn't it? Because it's Hopkins.
APL is fine for NSF, yes.
And then Russell, wouldn't university employees be okay? I'm thinking, for instance, Jeremy Faden in Iowa. I know he's interested in starting to write Python. We talked about it today, actually.
sure, of course, universities are good. I was just going by the responses I got from my announcement on the PyHC list.
Yeah, he was on the adapters effort too, and he also has a dual-headed option as his own company. But it's a for-profit company, but it's different. I mean, it's just him, really.
Yeah, so I'm technically not allowed to get NSF funding either, because I'm, in their words, an unaffiliated individual, because I'm a sole proprietor or LLC, depending on how you look at it. So I'm not allowed, but I do have an association right now with NumFocus. Right now it's just an affiliated package, but I've also applied for what they call grantor grantee status. So in that case, NumFocus would actually be getting the proposal, and then NumFocus would, provide me with the funds to actually do the work.
But the NSF won't do sole proprietors?
No.
Wow, because NASA will allow that.
Yeah, that's how I just submitted my recent proposal, was as an unaffiliated individual. That was my institution status, I believe. But that was okay. So I appreciate that from NASA.
We partially fund SunPy. I'm just thinking of the coordination piece. I guess if you win this proposal, we'd want to coordinate with you. I don't know, Jack is here on the call. I don't know if you can comment about that, Jack, or you want to, if I just threw you into the pool there and you didn't want to be.
Oh, no, no, this is a pool I'm fine swimming in. So SunPy has, maybe Nabil could also speak a little bit more on this, but SunPy does have a grant from NASA right now. One of the issues with SunPy is that, like a lot of our, as has just been mentioned, like a lot of our major contributors reside outside the US, so it is difficult to fund those people, even though we would really like to. So, but the funding that they do have did have a specific carve out for funding outside the US, and so that was allowed in that particular proposal call. Maybe Nabil can speak a little bit more about potential collaborations.
Well, just to speak on the grant, I'm not involved. I've not been directly involved with that, but my understanding is that when they applied for the grant, they asked in
Sound
England.
is not very good.
Yeah, Nabil, you're breaking up quite a lot there.
Maybe write a response in the chat.
Yeah, I'm not sure what's wrong. I assume this is still bad.
Sounding
Better?
okay now. Better talk quickly.
Okay, yeah. Sorry, I'm not directly involved with the grant. So my understanding was that when they applied, they asked specifically to fund non-focus, who then ship the money out of the United States to Stuart Mumford, who's the lead developer. That was a specific thing they had to ask for, and they got permission for that. So that might be something to consider. Yeah, I obviously I wasn't involved with the process myself, but that might be something to look into for that. In terms of collaborations with SunPy, yeah, I mean, we're always looking out for that, and money.
Yeah.
Well, not necessarily money is the problem. Also, there is a lack of enough manpower.
So Will Barnes is also, he's got his hand up and he is involved in this.
Yeah, let Will speak.
He's actually funded on this, so maybe like he can say something.
Yeah, I mean, no, what Nabil said is correct. So I am one of the people funded through this the NASA grant that we have that funds two of us at Goddard and then Stuart, who's working in the UK. And the way it's about Albert is really the one who kind of negotiated all the submission of the proposal. But I think the way it works is that NumFocus is a sub-award on our proposal. And then so NumFocus gets paid, NumFocus pays Stuart is basically how it works. And then I'm at Goddard, so then there's no problem there.
Thanks, Will. I should definitely talk to Albert about that, because HDRL does want to fund SunPy more, and if we can move money across in some legal way, then I'm all for that.
Yeah, I mean, I will say I think it was a pretty not painless process, mostly because of NCCS or NSSC, sorry, the people in Mississippi, the budget people. So you can talk to Albert more about that, and he has more insight on kind of the intricacies of all that.
Brian?
Yeah, no, I want to respond to several of these things. I completely second what Jack said about supporting SunPy, and I think there's also a broader interest in HDRL. That's the, if you don't know what HDRL is, Jack, Aaron, and I are all members of it. And it's essentially the NASA Heliophysics Archives and Research Software Coalition. Maybe that's a good enough definition for now.
Bobby is also here.
Oh, Bobby's here too. Sorry, Bobby. I'm trying to cut you out of it. And effectively other members who are on this, whether they know it or not, like Shing, Bernie, Darren DeZeo, Rebecca, and Will are either members or indirectly funded by HDRL. So we're fairly, I don't know, mysterious but large organization. Anyway, we're very interested in these kinds of collaborations, and I think I don't have time to read your proposal, Russell, but I think should you get awarded, we should very seriously consider how we can intersect with you from the NASA side to further enhance the value of what gets returned here through collaboration. Maybe that's the right words. And I think that this further magnifies the need for meetings like this. And I'll just throw it out there, the data environment meeting that was mentioned by John, that we're trying to organize in the fall. I think this is exactly the kind of conversation that would be facilitated by that and would result in very positive outcomes for our community, right? Because the community doesn't care how it gets funded, NSF, NASA, or whatever. What they care about is that it's there and it works, and that, you know, and also further collaboration. We have European colleagues on this call, right? So as a community, we should be coordinating as best we can, and I'm quite sure that we're not doing the best job of coordinating now. So I understand the irony of calling for yet more meetings from a guy that hates going to meetings, but I think in this case it's actually merited. And doing this more often than once a year at the IDEA meeting, right? Or in this 8S like meeting that John mentioned in the fall is the first step, but I think we have to intersect more often than this. Once a year is really not enough.
Thanks for those comments, Brian. Well, I haven't actually written the proposal yet because I'm still in the stage of, do I even have something to submit to, or do I just submit, you know, for the elements by myself, or can I actually go after the frameworks? I prefer to go after the larger framework, but I just need a larger development team to support that. And when I was talking with the NSF, they pretty much, well, not pretty much, they said their vision of it is like a professor with students, and that's a large team. And I was like, well, you know, I'm a former professor, but you know, that didn't really sway him. Now, so the foreign thing, when looking at the rules specifically said NSF won't send money internationally to a home institution to pay somebody international. But maybe if it's not sent to their home institution, maybe, you know, with the note before about it going to NumFocus first, and then to an international collaborator, I wonder if that might work in this case as well. Though, as noted, I expect that there would be additional challenges. So, and then the final challenge here is that this thing, they didn't release the notice until like September, and then I put the things out, and it would be due December 16th. So it is comparatively super short term. I mean, I can certainly get a high quality proposal together in that time, but if there's other hurdles that have to be jumped, then, you know, I guess we're gonna have to get on that for people that are interested.
Russell, I just wanted to make sure you saw Rebecca's chat there about possibly contacting Ensemble to partner.
I did not. Thank you for bringing that up.
She said, you might also contact Ensemble to partner with them for adapters into and out of Komodo. Oliver Gerland would be the contact.
Oh, perfect.
And you might request Asher, because he's back at Ensemble now. So you'll be splitting him with the effort for coordinate conversions.
Okay. Is Ensemble, can they get money indirectly or directly from NSF?
I have no idea, but they contract with us at NASA.
Are they a for-profit company?
Yes.
normal company? Okay, then, well, maybe through NumFocus, it might be the stage, because like I'm not allowed to, but I can via NumFocus. But the rules for NSF is that has to be like, has to go to a nonprofit research and type institution or something like that. So if, so I'm not sure if there's any room in any budgets for something like profit, right? It could only be person time. So I will definitely contact them. Thank you for the note, but I'm just, that's one of the particular challenges. Like NSF is kind of very restrictive, and it's frustrating.
Right. Okay.
Or maybe NASA can, offer up a $5 million proposal option for 5 years. That would be good too. That'd apply to that.
Those are out there. So one way you could possibly spin it, maybe this is off the wall, but here you go. One way you could possibly spin it for a NASA proposal is that the adapters would be, or adapter similar work would be a step towards AI ready data. So if you present a uniform interface for all of your data sets and uniform processing, so that the user doesn't have to understand the nitty-gritty details of all of the cleaning process behind it, you can just pull this clean data set and then run with it. That's a huge step towards having a data set ready for machine learning. You can, there's other thoughts that I've been discussing with others at Goddard on that. But that's an argument for any package in PyHC.
Oh, well, that's, I mean, truly, that's the base thing of what PySat does, is make independent, systematic access to all kinds of data sets that's uniform. What program was that?
I think the deadline just passed though. It's a NASA Roses thing. You know what? Let me try to
It
look
was
at the link.
F9 on AI. And yes, the mandatory notice of intents was unfortunately yesterday for that.
More flexible program is B20, Heliophysics Tools and Methods. And it specifically says in the call that you have to strongly consider contributing your project to PyHC, hint, hint. So it's...
But that's smaller projects. That's not big.
Yeah, it's smaller stuff. So it's usually the grants are 50 to 100K, but it could get you off the ground. Yeah.
I am planning to submit like a 100K grant to one of those programs. I think it's the HDEE side, but and that'll be coming actually here in the next few weeks. I just wanted to get through my last proposal, which just went in.
Yeah, so B20, and I guess the other one is B21. I forgot, but they're both very flexible submission dates. Like it's just a rolling date.
Yeah.
You could get it in at any time, but they review only once a quarter.
Yeah. Yeah, I've seen that. I can't, I'm disappointed, but at the same time, not surprised to hear that the perfect program that F.9 just closed, the date was yesterday. Oh, well. Yeah, so it could be, it doesn't all have to be PySat. That is just, I'm starting with PySat, but, though bringing it up to the community was for all kinds of different packages to get together. It's just not for me. My interest was trying to support the larger community and larger community efforts because it had the budget to do so. So anybody that wants to participate in any kind of thing like that, then yeah. So I will definitely contact some of the people. The people that that mentioned to me here and that I've written down. But if there's anybody else or anything like that, please feel free to send me an email or russell@stoneris.com. So. All right. Well, thank you.
Thanks, Russell. It looks like there's some more chatter in the chat if you want to continue it there.
Okay.
But now we'll move into the last bit of discussion we have planned for today. There was originally supposed to be a whole panel discussion at the test meeting for the session that PyHC had been also involved with, but ended up not working out and happening. So I asked Arnaud if he would like to lead it here instead. So Arnaud, would you like to introduce us to the idea?
Yes, we ran out of time at the test meeting, so we were already half an hour late. so definitely no time for discussion.
That was a whole thing with like the other room's microphone blaring into our room.
Yes, we had some technical difficulties. not our fault, but okay, this is life. I will share with you one slide. So there were some themes, those are some themes of discussion, and that were mostly suggested by Rebecca. So thanks, Rebecca, for this. So I wanted to, so I basically copy pasted those, but those were approved by the TESS Open Science Session conveners. So here they are. So how do we advance the use of software tools to progress towards open science in the heliophysics and space science domains? How can we address accessibility and interoperability challenges in Sun-Earth connection science? What are some practical tips to handle diverse data sets from solar physics to Earth science to enable interoperability between programming languages? What are the needs and requirements of the ideal shared online infrastructure? And also handling legacy code written in older or closed source languages, as well as simulation code, intensive calculation written in compiled languages. So that was some of the themes that we wanted to discuss during this panel discussion. So so some are general, so some are more specific.
Jack.
Yeah, I can say a little bit about the very last point about legacy code since SDAC funds the development of SolarSoft. So what we're thinking at the moment is that SolarSoft will continue as long as the missions that SolarSoft supports continue. So at the moment, that's SOHO, which is we're planning end of life for that and to December 2025. There's IRIS, SDO, Stereo. At some point, these missions will, no longer be operational. So the plan at the moment, at least, to like sunsetting the legacy code is whenever these missions stop. Now, for example, SDO have AIAPI is a good example of like taking code that was originally written in IDL and then moving it into Python. So maybe there could be like more of those kinds of efforts in the future. But at least, for SolarSoft, we're sort of thinking we'll stop funding its maintenance. Really, there's not a lot of development when the missions that use SolarSoft are no longer operational.
But do you think we can transition the SOHO calibration routines to Python, or is that realistic? Or
I don't think so. I mean, for the example of SOHO, like for people who don't know, there are 12 instruments, 12 instrument packages on SOHO, and it was launched in 1995. I think the level of effort is too high to do everything. The expertise, frankly, doesn't exist for some of those instruments anymore. SDAC is planning on funding an effort to recalibrate the LASCO data, and that effort is largely Python-based. So I think for the bulk of SOHO, at least, it's probably not worth the effort for to redo everything in Python. LASCO is a bit of an exception since it has a lot of the space weather aspects of LASCO are
sure,
kind of second to none, and so that data set is already one of the most important ones in Soho, and we expect that to be the case going forward. So, but for the rest of the data, there's a lot of finalized data products out there already. And so we hope that moving to like making sure that the finalized data products are around, so you don't need the data prep routines in the future. That's really where we want to go. So actually, in the last couple of weeks, we've had, and there's an instrument called UVCS, which was which is on Soho.
Yeah.
And they've been finalizing their data products in the last couple of weeks. So I think that is the kind of effort which would be worth effort. Rewriting the algorithms, perhaps not so much.
I think it totally makes sense. And for a number of experiments, you have mission long files, which are basically the final version of the files, which is great. So there's been recent progress on the Zoomer experiment as well. So that's looks very good.
Yeah. Brian, your hand's up, but really quick before that, these kind of discussions are often well facilitated by using the Miro board option. So to answer some of these questions, if you click on the link Rebecca put in the chat, you can go and put like little sticky notes and things below the questions with your own ideas. And that's something that we can capture and then have be, persistent after this whole conversation finishes. So feel free to hop on there with ideas. But Brian, go ahead.
Yeah, I don't know. This is a lot of questions with a lot of issues behind them. We could be talking for hours. But I want to respond quickly to Jack's response. I start by saying I second everything he said, but I think we can take it in. I took the question in a slightly different direction when I read it. It was really about, for me, enabling open science. And when we look at closed source languages like IDL or MATLAB, I am not smart enough, and maybe somebody else in this audience or elsewhere is, but I don't see, and this has been, and I didn't even come up with this idea, this Aaron pointed it out to me, I don't see how we're going to do it. You can't have transparency and reproducibility if it relies on a closed source language, and somebody else doesn't necessarily have a license for it, and these things aren't necessarily built to last, to be able to run the version of IDL that was resident in 1995. I don't even know how you do that. So we have to move away from them, is my conclusion, period, full stop. And at NASA, I will certainly be pushing for any new mission to not do any IDL work, to not add yet another SolarSoft mission. And I just don't want to see that at all. Now, there has been work by the HelioCloud team. I think it's Trevor, has been looking at GDL as a sort of open source drop-in replacement for IDL. And that might be a way of transitioning some newer closed source code that's been published in the research to be truly open source. So there's hope there. I think there's a similar one for MATLAB. Somebody told me the other day. I'm not a MATLAB user, so I'm not aware.
Yes, Octave is the one for
Octave, yeah.
Yeah, somebody said that was better supported than even GDL in relative to the closed source version. So I would advocate that the community spend time investigating that rather than trying to wring hands over how we carry closed source into the future. We should just say no. Just say no. I'll just borrow a line from Nancy Reagan. Yes, if you're old enough to recall it. We should just say no to closed source languages. We should maintain the support where it's required, as Jack mentioned. But we really shouldn't have any new missions or any new projects that have dependencies on these things. That should make the PyHC folks happy, I would think.
Indeed. Or no, I don't know if you've yet clicked on that Miro board link, but Rebecca started setting up all of the questions that you had here on the slide, and people have started giving some responses to them.
Okay, I'm a bit blind by sharing now. So
No worries, no worries. John,
Arnell, could you quickly paste the last 3 things in the chat so I don't have to read and type on different screens?
all right.
Can you do that?
Yeah.
That would be so much faster. Sorry, Julie.
That's fine. I was just going to follow up with with Brian's comments about, you know, and some of these questions, how do we advance the use of software and tools? A lot of the tool money in heliophysics is tied to the missions. Missions will develop tools for the things that they want their teams to do. I really think that we should have that mission effort required to also have a community focus. That's extra requirements on the mission. So it can't be an unfunded mandate. There should be some kind of joint like tools mission collaboration that could be set up, or missions could propose an extra piece that says, here's how we're going to leverage community tools to do what we want to do with our mission. Missions have to be focused on their deadlines and their, you know, level 1 science goals and that. But if we add other things to that say, look, let's take what's being done by the missions and make sure that it's compatible. It doesn't have to only be community tools, but if they want to develop something specific, there needs to be a reason. And so I think that's one way. Another thing is, you know, how do we address interoperability and accessibility? Well, I mean, it has to be the same somewhere, right? So that then you start talking about standards. I don't think we talked about this in the adapters thing. What would be the universal ideal data model everybody could use? And Brian was like, what are you talking about? That's impossible. And we kind of definitely agree with that, right? So having a small set of standards, there's a right sizing of that. You know, you need to have enough flexibility so that you can fit in everything, but you don't want to have so much that you can't adapt it. So having the right set of standards, finding the right layer where you won't change things for a long time, and then you can commit to it. Because it's very self-serving, right? This is talking about happy and stuff, but you know, that is solving a problem that we've been facing for a while, which is just slight differences in diversity. But overcoming those is key. Getting everybody on the same page about it takes forever, but it's worth it.
And I'm still fired up from that discussion. I had to have like 3 desserts that night, and then I went out for a 20-mile run, and it just didn't help.
Sorry about that. We just
and now thanks, John. You just brought it right back up.
Threw salt right back on the wound. Yeah,
I know. Universal data model. I'm gonna mute now.
Arno, Rebecca does have all of the questions now on the Miro board if you wanted to click on that and share that instead.
I have to acknowledge my lack of knowledge there to go to this Miro board.
No worries. She pasted the link above. Julie, you could share.
Okay.
I didn't even think about that.
Sorry.
I'll share.
Okay, now.
Of course I can share.
So the way it's typically moderated with a Miro board is the entire group focuses on one question for a couple minutes, and then after however much time, you move on to the next question, and then you iterate through that, because then we get everyone's ideas on each question, and it's still open after the conversation, so you can add more ideas later, but there's some ideas and then some conversation about each question.
Yeah. So I have it panned in currently on that first question. How do we advance the use of software tools to progress towards open science in the heliophysics and space science domains? Feel free to throw in your thoughts.
I think this adapter work is one big piece of that. Julie, can you zoom in a little bit?
Yeah.
It's hard to read the sticky notes. Thanks.
Worth
I guess I
mentioning,
could.
you mentioned the adapter work. There'll be a poster on that and a lot of other PyH things at AGU. Do we want to set up a little sidebar PyHC tag up?
Sure. I'm all for it.
Yeah,
What session is that going to be in?
there's a lot of them.
The PyHC sessions?
Yeah, aren't there
No,
two?
no, no, the adapter poster.
Oh,
Uh-oh. I will email that to you because
Oh, can you add it to the Miro board?
if I can find it.
Both. Let's go with both.
oops, sorry. Barbara, what does LWS stand for again?
It's living with the star.
That's the Living with the Star, heliophysics tools and methods.
Yeah.
Yeah, that was the one that they were just talking about, how it directly, talked about the involvement of PyHC. But I do know from a discussion about that they were, as they had it worded, it talked about what's the science utility. And that was still being used as an evaluation criterion for the proposals. And they're open to possibly funding it not through the roses, but through the technology area, so that if you have something that's like a broad science use, but you can't just be like, we're going to address this particular science problem, it won't be an obstacle to funding. But they would, I know that Lika Guhathakurta, Rainer Friedel, and people like that are interested in knowing, like, is the model for funding development of these tools and methods, particularly ones that are connected to an ecosystem, the way it's doing it, is that successful, or is there, is there a better way of doing it? So instead of just putting this down here, I think it would be good at the next meeting, or maybe at an upcoming, just to kind of have a general discussion on, you don't really advise NASA headquarters, because they have lots of responsibilities. But if they could have a discussion of if PyHC could talk about at least some of the factors involved in a useful way to help them understand. I mean, Aaron Roberts knows this very well too, so I'll defer to Aaron, of course. But I do know that we were on a completely different topic, and this came up and someone had mentioned that they were frustrated that some of the good proposals were getting dinged because there wasn't a targeted science thing. And it kind of rolled into, well, how do we fix that? And, and it was agreed that the PyHC, in particular, the PyHC community, could at least, with all of the different users involved and what they think would be valuable and whether they've been having trouble getting support for it, could provide at least feedback on the difficulty getting consistent support. So I didn't want to put that in a post-it because it's long.
Well, luckily, we're also recording this, so your comments are captured.
So there's quite a few ideas on the first question. It seems like a good time to move to the second one.
Yeah. Awesome. Thanks, everyone. These are some really good ideas.
These are really good.
Yeah.
I should point out, we've got 3 minutes technically left on the docket here.
Yeah.
I'm enjoying this enough that I could stay a few minutes longer, but if anyone has to.
Yeah. I understand if people have to log off, no problem. This link should be persistent after this. I think we can have it open for a bit, Rebecca, for people to keep answering as they're able. So if you wanted to come back to it later today or something, if you come up with some cool ideas, feel free. But I can also stay a couple minutes longer too. So yeah, question 2, how can we address accessibility and interoperability challenges in Sun-Earth connection science?
Yeah, I'm gonna make a note of it here so that it's saved, but to say it out loud before I take the time to write the note. This is on my personal wish list of getting us to a point to where we have a common PyHC environment that works with all packages related to what I was talking about, I think yesterday, and Brian's effort with HelioCloud and all that stuff.
So Brian, carry on.
It would be beautiful if we got to a place to where every single PyHC package could be imported into one project with one Python environment, and then suddenly, if anyone makes an update to their package that breaks the compatibility, we wag our finger at them and we have them go back and address it.
Sean, I think that's your job. And
It kind of is my job. I am the tech lead.
Yes, I think it is. I mean, I don't know how to have that be enforced, but have you guys have more of a technical input and effort? Like Brian was struggling, oh, I need to get all these working together. Are they different versions? It's like, that's where, I think that's what PyHC funding should partly go for, or should be focused on, is making these things compatible and work together, even at the technical level, like contributing code and helping people migrate and so forth, so that it's all compatible.
Oh man, I'm trying to get out of this call and you're dragging me back in. I have to quickly respond.
I need to go too, but yeah.
So basically, yes, but I think there's no single human being. Sorry, Sean. I know you're talented, but I think that we have to seek a solution that's curated by the PyHC staff, but engages all of the developers in PyHC to sort of clean up their own messes and coordinate. And PyHC is more of an enforcer and a provider of infrastructure where that can take place, I think is maybe a better model. I've suggested such privately to Julie. They're rewriting their grant, I guess, and I've suggested that they put language or things like that into it. So I'm hopeful that indeed we can make some kind of shift in this direction. I await, Aaron and I await your new proposal, hint, hint, wherever that is, or maybe you send it to Aaron, but I didn't see it.
But having PyHC staff forge the way on 1 or 2 packages. Hey, here's how we connected this to like a yearly build or a yearly deployment of PyHC. Here's the deployment that's all fully compatible.
Yes. 3 thumbs up on that. And I can't, I did this once and I'm still doing it, but I can't do this ad infinitum. You really don't want to rely on me. So
I'm going to put your 3 thumbs. I put that on a sticky and I'll say, Brian says 3 thumbs up.
Yeah, this actually sort of relates to a sticky note I put in the last one, and I'll refrain from making this a general discussion. I'll just comment it again, that it's been on my wish list for a little while to have a third person be kind of hired by PyHC, so to say, like me and Julie. Because yeah, I am the tech lead, but I often in practice get bogged down so much with like managerial and organizing work, like putting together this meeting, for example, that I don't get to spend as much time as I want actually in the technical weeds. So having a third person either to do more of the organizational stuff or to be just a technical developer would go a long way toward actually making that happen. But me and Julie have talked about that offline, and it might be part of future like funding re-ups and stuff. So
put it in the proposal and we'll work it.
Okay.
That could also be a rotating thing that goes around to various package holders that, you guys show how to do it for a year or 2. And then it's like, okay, and that's a rotating position that coordinates with the main PyHC folks, but that role rotates around so that that funded expertise can be built up multiple places.
Yeah, I think that's a good idea. I'm trying every year to get people to come up with ideas for how we use this sort of central resource. And something like that could be good.
So again, there's a growing number of ideas on question 2. Maybe take a moment and then move on to the next question.
The PyHC gallery shows up. Yeah. Feel free to wrap up your thoughts here. Ooh, question 2 already has some good ideas too. So the next one, what are some practical tips to handle diverse data sets from solar physics to earth science to enable interoperability between programming languages? We have some ideas already posted, but if you have any other thoughts.
I'm gonna put one in here that's maybe a little bit tongue-in-cheek, but also as practical as I can imagine. I deal with people formatting their times in their data sets very stupidly all the time at last. Things like, in an ASCII file, they'll have one column for like the day of the year and then another column for the time during the day, as opposed to just making it one ISO string or something like that. You'd be amazed how many creative ways people come up with representing time in their data sets.
This
Sean,
just
you
shows,
cannot surprise me. I deal with
this
model
just shows
data.
that you're young, Sean. This just shows that you're young.
People have been screwing
Creativity
that
in
up for
time formats
decades.
was incredible over the years.
Yeah.
And that's one of the main things that things like CDF solve. If
happy.
CDF only solved the time problem, or CDF or HDF, choose your flavor, but that would be an enormous step, and that's basically one of the things that it has done. And why ASCII is discouraged, because ASCII lends itself to 5-column times.
This is great, but I have to jump off. Sorry, everybody. This is really good stuff. And this demonstrates why we definitely need a conference. There's so many good ideas.
I was totally muted doing what I just said. Thanks, John. Feel free to keep adding to the Miro board later today if you have.
Yeah, and actually having this little board as an output of this discussion makes it a way better outcome than just talking about it at tests into the air and then it vanishes forever.
Yeah.
So it's actually sort of serendipitous that we ended up doing it now.
I'm a big fan of it. I think I'm going to incorporate this in the future meeting discussions. This is a cool idea.
Go for it, Julie. I've seen it done a couple times, particularly by Ryan McGranigan, and it almost always goes well. There are some cases it just falls flat, but
yeah, Ryan's really good about using new ideas like this to make discussion even better.
I would think for sake of time, we need to move on to the 4th question on the bottom.
Yeah, I would agree. So question 4, what are the needs and requirements of the ideal shared online infrastructure?
let's see, how do you do the little arrows to connect notes together? Is that on this sidebar here on the left?
I think
Yeah,
so.
the sidebar, there's
Connection line
the,
probably?
mm-hmm,
Yeah.
yeah. That. You, I wonder what this does. Oh, you can add comments with the little chat thing.
Good stuff.
And you can play with it. Sticky notes are the most common thing.
Oh, this is sort of unrelated to this discussion, but just while anyone's still on the call to hear it, I heard back from two people about what I had talked about earlier today. One, the Roar folks already got back to me and agreed that other was the right choice, not nonprofit. So they updated that request for us. So no actions need to be done. And good news, I just heard from Tess and they're officially interested in getting a proposal from us for a 2024 solar eclipse event.
Cool. Can you forward me that if you haven't already?
Yeah, I could have sworn I CC'd you on the last one, and it's a shame.
Okay. If you did, I'll check.
No, she didn't CC you, so I'll forward that to you.
So let me put on my CCMC hat for a moment. I know CCMC, we're not interested per se in doing our own event, but we're willing to be a strong supporter of someone else who will do it, such as the PyHC team.
That you'd be a good group to have.
Yeah.
Yeah, I mean, we have Russell's idea about having the whole real-time stuff going on fits perfectly in with a lot of the features and services we have at CCMC, such as ISWA.
That is
ISWA
what
comes to mind.
Yep.
What
I
was
have
that?
pitched to do a real-time data display to
Well, that's what ISWA can do.
Yep. Get all of our packages here that actually deal with real-time displays to beef up their capabilities such that we could make a real pretty display of a whole bunch of different data streams during the eclipse. And then, 10, 15 minutes after the eclipse, go look to see how the data changed. Nothing too crazy, but it's a carrot for package developers to actually finish making those features. And then it gives us something sciencey to look at after the eclipse and gives us a reason to go meet in person to do it.
One thing, if you don't want to build it from the ground up, you could talk to Richard Molinex and make contacts with leadership at CCMC to either imitate or incorporate. So you can make widgets, well, signets is the word, into ISWA. But that does require some of Rick's time. So maybe some sort of compromise or like internship or something could be arranged. I don't know if it could happen. Well, that's 2024, not next year. Maybe. Like if you get, say, 5 signets built by the time it comes, and that can be in ISWA, that would be, I think, an easy way to do it than trying to build your own ISWA. But you'll have to think through that on your own too.
Did
I mean,
you say,
I
heard Richard. What was the last name?
Oh, let me put his name in the chat.
And you're saying a word that sounds like ISWAT, but I don't think you're saying ISWAT.
Oh, no, I am not. Sorry, lingo. Let me pull up the correct page and put it in the chat. In fact, if you want, I can show my screen and show you what I'm talking about.
Let's keep the focus on this board for now, but I'll take the link.
That's probably the best call. I'll put the link in the chat. That'll be enough.
Thank you, Rebecca.
Sure. There's the chat.
And with that, I think I'll go ahead and encourage people to move on to frame 5 of this board, and then we can wrap up by like 15 on the hour.
Yep, that's what I was about to say. Last one now. This was dealing with handling legacy code written in older and or closed languages, as well as ideas for how to handle simulation code and intensive calculation written in compiled languages.
Simulation code in compiled languages. Put it at CCMC.
Oh, sorry. Totally switched screen. Where'd the Miro board go? There it is. Forgot I was sharing the whole Google Chrome.
We deal with models in all sorts of languages. But it's only for simulation code. We don't do this for like package features. Like SpeedS would not find its home at CCMC, for instance. Even though it's an IDL and it's calculation code, it's not simulation code. So. Who put the 1x(m) feathers? Working effectively with legacy code. What is that about?
I'm sure.
I probably had the drop off already.
All right, I'm gonna let people continue to add to this board, but I'll just go ahead and share the like 2-slide wrap up I threw together last night to end the meeting. Go to that. Okay, cool. Feel free to keep adding to that board though, as you so choose. Certainly throughout, maybe the end of today or tomorrow. I welcome all ideas. Okay, so wrap up for those of us still remaining. Thanks for everyone who came and made it to this meeting. I think it was really productive, especially now this last discussion session has turned out to be producing a really great deliverable with this mural board. But as far as upcoming meetings goes, we have the AGU 2022 meeting where we have several different PyHC sessions that I encourage you all to attend. There's an in-person poster session, an online poster session, as well as an in-person oral session, which is the first time we've ever done something like that for PyHC. So I'm really excited about that. And all of these are linked on the slides, which are on the meetings G Drive, but these are also linked on the meetings webpage that is on our PyHC website. So feel free to look there for those. And of course, as usual, we'll have, I put spring 2022, that should say 2023. There'll be a spring 2023 meeting coming up, probably sometime in the May timeframe. Format, I said TBD, but I would really love to actually make that a hybrid one this time around. I think it would be better for facilitating discussions and so forth. Probably be a similar format as what we did when we first started the whole group, which is like a 3-day meeting, one of those days being a half or a full day, maybe for some good in-depth hackathon sessions, and likely to be held here at LASP. So be on the lookout for more details about that. And then as telecons go, probably gonna try get one more here in November, probably after Thanksgiving, and then we'll break until January on telecons just because there's too many meetings going on, holidays and so forth. So as far as this meeting went, the general questions, feel free to share your thoughts with me, what worked, what didn't, what should we do differently next time. I'm going to put together a survey so you can also be anonymous with your ideas and send that out to everyone after today ends. And yeah, I already talked about the possibility for the in-person for spring 2023. So hopefully COVID doesn't rear its ugly head again and make that impossible. Go ahead, Rebecca.
Is there any thought about a PyHC summer school coming up?
Not for this year. We're going to have it be biannual.
Okay.
Awesome. Well, you're more than free to keep hanging out and, adding to the Miro board if you want, but I understand everyone's got commitments and we're 20 minutes over. So feel free to drop, and thanks everyone for making it.
Yeah.
Bye-bye.
Yep. Good to see you, Arno.
Thanks.
Bye.
Bye-bye. Thanks.
Thank you.
Okay, bye.
Especially thank you to our European folks. It's really late now.